Hello, for this lesson we're talking about terminating and repeating decimals. But to start this lesson, I wanted to go over what your textbook was looking at, and that's a review of what rational numbers are. Okay? Now, quite frankly, we have down here, I started running out of space, I apologize, but hopefully you can use context clues and figure out what that is. Okay, it says rational numbers can be written as fractions. Okay? So, very simply, rational numbers are numbers that can be written as fractions. And rational numbers, it's a very, very broad term. Okay? So, rational numbers, any numbers that can be written as fractions. So, within that, we've been talking about integers. We've been talking about whole numbers. Okay? And so, rational numbers is a very broad term. Integers is a more specific term. And then whole numbers is getting even more specific. Right? So, if we talk about these things, okay, let's talk about like whole numbers. All right, whole numbers, those are numbers like 2, 3, 5, 99, right? Those are whole numbers, okay? Numbers that you can go out and you can count. You can go, oh, in the park, there are 99 trees, right? Those are whole numbers, okay? Whole numbers do not include negative numbers. They do not include fractions, right? Partial numbers, like they don't include decimals, okay? Whole numbers are a very specific set of numbers. Now, integers include whole numbers, but they add a few more things. So all these whole numbers are also integers. Okay? Integers, what does it add? Well, it adds the negative form of these numbers. So like -2, -4, -7, okay? Those are integers, okay? So 2 is an integer, but it's also a whole number. -7 is an integer, but it is not a whole number because whole numbers don't include negative numbers. Now, something that sometimes can trip up some students is something like this, right? Remember, I told you that integers, it does not include fractions, okay? Or mixed numbers, parts of a whole, but notice, -2/2, what does 2/2 really equal? 1. Okay? So, that's not really, it's not part of a whole. It is the whole. Okay? So, it's a whole -1. Okay? Now, rational numbers, they include integers, right? An integer, -7, is a rational number. The number 5, it's a rational number. Okay? But, rational numbers are going to include things like, mixed numbers, 2 and 1/2. That's not a whole number, it's not an integer, right? Because it has 2 whole and 1/2. Okay? It could include the decimals, right? 0.2. That's a rational number. Okay? Now, this lesson is titled Terminating and Repeating Decimals. So what do those look like? So you could see something like this, 0.3 repeating. Okay, that's called a repeating decimal. That means that it's 0.33333 on to infinity and beyond. Okay, a repeating decimal. We notice I have a fraction bar over the value that is repeating. Okay, I don't need more than 1 3. I only need whatever is repeating, and I put a fraction, or sorry, a repeating bar over it. Okay, so we also have terminating decimals. That would just be something like 0.2. All right, terminate. Terminate means to end. So 0.2 is a terminating decimal. Now this whole concept of this is the broadest term, this is, a more specific term, this is even more specific. Okay, sometimes that's hard to grasp. So I'm going to do a really quick example. Talk about hopefully something you'll see maybe a little easier. Okay? So, we have, over here, we have the broadest term, right? Athletes, right? Getting more specific, basketball players. Even more specific, we have, the Lakers, okay? So we can talk about, let's say, for the Lakers, if we're talking about the specific ones, well, we have, LeBron James, right? LeBron James, very good player, right? He's a Laker, okay? We have Danny Green. Danny Green is on the Lakers. And many, many others. Okay, but so Lakers, we have those. Now, Lakers, they are basketball players still, right? But there are lots of basketball players who aren't Lakers. Okay, so we have maybe right? Chris Paul, right? We have, Porzingis. We have lots of different ones who are basketball players, but they're not Lakers, right? So we see how we can have more specific terms. And for instance, athletes. Okay, athletes, it's really, really broad, right? LeBron James is certainly an athlete, but right, not all athletes are LeBron James. Okay, right? For athletes, you could think of, there's Mike Trout. As a baseball player, you have Tom Brady, right? Just signed with the Buccaneers. Okay, so athletes. So we see this example of where you have something very broad and get even more specific. But every single time, as we get more specific, right? LeBron James is a basketball player. LeBron James is an athlete. Danny Green is a basketball player. Danny Green is an athlete. Okay. All the players on the Lakers, they're all athletes. But not all athletes are Lakers. So that's kind of talking about how we have those umbrella terms, right? The things that cover other things, right? The athletes, it covers basketball players, it covers Lakers. And that's what we have with rational numbers, how rational numbers cover integers, it covers whole numbers. But not all rational numbers are whole numbers. So now let's look at some problems that you will have on your homework. Okay. So, in the first section it says, write each fraction as a decimal, use bar notation if necessary. So you would use bar notation if it's a repeating decimal. So, 80 divided by 99. 80 divided by 99, okay? On my calculator, I get 0.08080808, and I actually get a 1 here, okay? So, looking at this, and I'm going to just point out something here, okay? Looking at this, it seems like it's repeating, right? 08, 08, 08, 08, and then we get a 1. So, does that mean that it terminated right here, or is this really a repeating decimal? I'm going to give you a hint. Your calculator only has so much space, and it's set to usually round at a certain point. So what I think would have happened here is that it continues to be 0.8, but it reached that point on your calculator where it says, okay, now it's time to round. So, for here, that 1, that was it rounding. So what I'm looking at is actually 0.080808. So that's a repeating decimal, which means to answer this, it's going to be 0.08. And I need to determine what do I put my bar notation over, okay? Well, do I just put it over the 8? So you need to determine what's being repeated. 0.8, so that would be wrong, right? The 0 is being repeated. It's 0.8, 0.8, 0.8. So make sure whatever is being repeated that you put that bar notation over. Okay, for number 2, we have -2 and 3/8, right? -2 and 3/8. So, for this, when we have a whole number here, right, when we have that whole value, that integer, that -2, guess what? That's going to stay the same, okay? -2 remains the same whether it's in decimal form or if it's as a mixed number. What we need to find is what is 3/8 as a decimal. Well, we plug that into our calculator, 3/8. That equals 0.375, okay? Well, I know my whole number is this, right? I have -2, that whole integer here. I'm going to get -2.375. So I just plug in, when I turn that fraction into a decimal, I just plug it onto the end with that number there, right? So that -2, that remains, so I plugged my decimal value onto the end. And I know this did not get to the point where my calculator would have rounded. There's nothing this would have, this is not a repeating decimal. It terminates. I know that there's no issue on my calculator. For number 3, I've got 4 2/5, which means I need to take my 4, take that whole number, and that's my whole number in my mixed number and in my decimal. And then I have 2 divided by 5, and that's 0.4. So I just put 0.4 after that. So I would get 4.4 as my value. For the next section, it says write each decimal as a fraction or mixed number in simplest form. Okay, well, what I'm going to do first of all, I notice I have a negative sign. Okay, so I can take that negative sign right away, because if it's negative as a decimal, it's going to be negative as a fraction. Okay, the next thing I do is I look at the very far end and I say, okay, what is that place value in? Right? If this is the tenths, that's the hundredths, which means I put hundredths as my denominator, and then whatever value I have here. So this is 97. Okay, 97. It's 97 over 100, and I need to look: is it in simplest form? Yes, it's in simplest form. Okay. Number 5. 5, again, just like we had up here. If that's a whole number there, that whole number is the whole number of your mixed number. Okay? Right here it was 0, so I didn't have to put anything out there. Right? It's negative 0 and 97 100ths. I don't need to put a 0 there. For this one, it's 4, and this is in the tenths place, so it's 4 and 2 tenths. Okay? Can 2 tenths be simplified? Yes, it can. It would become 4 and 1/5. Now, I wanted to add in, I saw in your textbook a problem like this, so I wanted to make sure we covered this. Okay, talking about absolute value, so bringing in, this other type of rational number where we have a negative rational number inside of absolute value. So how do we deal with this? Oh, it's so overwhelming. Oh my goodness. Well, no, not really. Remember, absolute value, that's just the distance the number is from 0. Okay? And absolute value, it's always positive. So it's simply the positive form of this number. Well, if the number inside of this absolute value is negative 8 and 4/13, well, then the absolute value of that is positive 8 and 4/13. So don't get tripped up by the fact that they're throwing mixed numbers, negative mixed numbers into absolute values. You're going to do just fine. Just remember what absolute value means. Okay, remember it's always positive. Good luck on your lesson.